The construction methods proposed for building the bridge have been extensively used by FEDIN. The construction of the main bridge for the river crossing will begin with the sheet pile cofferdams for the foundations, using maritime equipment. Piling and pile caps will then be completed, placing the equipment on the finished backfill. The piers will be built using climbing formwork in 5 meters high sections with the assistance of a tower crane with a range of 70 meters, previously installed on its footing. The deck of the main structure will be built in 2 stages. In the first stage, the central box will be built using 3 meters long precast segments. In the second stage, the side cantilevers will be built on site. Construction of the first stage begins with the 2 towers closest to the Romanian side abutment, with the assembly of the so-called zero segments, by means of a device that attaches them to the 2 towers of the pier. These first 2 segments will be brought to the base of the towers using a 500-ton crane mounted on a barge. Once attached to the pier, the 2 pairs of mobile lifting equipments are installed on them, starting the precast segment assembly process on both towers at the same time. With each of the pairs of mobile lifting equipments in place, 8 segments are placed 2 by 2 in the first stage, on each side of both towers. At this point, segment assembly is stopped in order to cast the sloping struts by shoring with formwork, supporting the shoring on the surface of the sheet pile cofferdam. After finishing the struts, positioning of the segments is resumed at both sides of the tower. When a pair of segments with stay cables is reached, assembly is stopped and the cables are fitted. Once all the pairs of segments on each cantilever have been fitted, the lifting equipment is dismantled and the span closed by the on-site casting of the closure segment. At the same time, the first 25 meters of viaduct will have been constructed on the Romanian bank abutment by means of a frame shoring, supported by a provisional pier. The 2 pairs of mobile lifting equipment are then moved to the remaining 2 piers, continuing the process until the first stage of the deck construction is completed, leaving it ready for connection to the first section of the roadway approach. The second stage of the cross-section will start from the Romanian bank abutment, moving towards the center of the river after the assembly of the 2 mobile carriages required for the cantilevers in the initial section. These carriages will continue their movement until they reach the junction point with the roadway approach viaduct, where their work ends and this part of the bridge is completed. Following the construction of the foundations and piers in a similar manner as for the main bridge, the deck is then also built in 2 stages. The first stage will begin at the abutment end. The central box is made of 2-meter prefabricated segments fitted using a large launching girder, one edge of which is supported on the already built area and the other on the following pier. At the initial position, the segments of the first T are fully installed from the abutment to the center of the second span. The launching girder is then shifted forward to the second position in order to build the second T. This is then connected to the previous one using a 50 centimeter casted on-site closure segment and starting a new cycle. In the second stage, the side cantilevers are casted. To do so, a carriage is installed, leaving the central part free for access of a 100-ton straddle carried in new segments, at the same time as the cantilevers are casted. The railway approach spans are built on site in a total of 24 stages, 16 of which are built using a launching girder for the formwork support. This provides all elements needed to cast one full section and the equipment to move forward and guidance for positioning purposes. The use of the launching girder allows for the industrialized construction of the bridge, leading to very short cycles and great performance, allowing construction output of 1 stage per week, including all operations. The remaining stages are built using tubular shoring due to the fact that they have special characteristics that prevent the use of the launching girder. Throughout its history, FEDIN has built worldwide many unique viaducts using a wide range of typologies and construction methods. It has all the knowledge, experience and equipment necessary to face the difficulties posed by this construction with full reliability. On the other hand, the engineering consultant company Carlos Fernández Casado has designed many unique bridges, including the cable-stayed bridge over the Barrios de Luna Reservoir, holding the world record for its type, the cable-stayed bridge Sancho el Mayor, the bridge over the Guadalquivir River, and the cable-stayed walkway over the Manzanares River, obtaining world fame with awards such as the International FIB Award, the Fédération Internationale du Béton, in 1996, and the 2006 International Award of Merit in Structural Engineering from the IABSE, the International Association for Bridge and Structural Engineering. Thus, FCC Construcción and Carlos Fernández Casado are able to ensure that the design presented complies with all prescriptions of the tender documents, guaranteeing its feasibility in both terms of cost and completion time.